conducted on very small samples, and it does not require in extensive sample preparation before the measurement also. For example, if you are putting any particular object under microscope, so you do not have to go through the sample preparation as such, like we do in the destructive techniques like chromatography. All right, if you know the basics. So moving forward, so with these advanced techniques, quality and precision requirements, they can be met efficiently, and this is an important step in the official recognition of quality of the laboratory also. So how well the laboratory gives the result with the minimal consumption of evidence, as well as giving the uh, extensive report of that particular uh, evidence. So that, yeah, so that particular technique, it is, just a second. Yeah, so that particular technique, it is developed. That is the non-destructive technique, and that also marks the efficiency of that particular laboratory. All right. I hope you are able to see whatever is shown on the screen, because I'm having some network issue over here.
No, ma'am, it is just one slide that is being shown. No.
Yeah. So introduction is written over there, right?
Yes, yes, ma'am.
Okay, okay. Now, moving ahead, so the use of various instrumental techniques, it has become an important part of analysis in various fields of science, for example, in pure science as well as applied science. And we all know that forensic science, it is a part of applied science. It is an applied science, not pure science. All right. So, only a single instrument, it cannot solve an analytical issue. Instead, numerous instrumental methods, they are necessary for efficient analysis to a maximum extent. Now, the chemical sciences, it serves as a proof of various evidence and evolution of technologies, which has led to the growth of high performance instruments. So we often come across the chemical instruments which are used for analysis of for toxicological and chemical analysis of substances. But in biological laboratories also, apart from microscopic examination, there are so many techniques, there are so many instruments which are used, and eventually we just neglect the use of those instruments because we feel that the preliminary, just to avoid the you know to avoid the additional steps to give the confirmatory test, so we avoid doing further steps or further examination of that evidence. So that is there. Now, the chemical sciences, it serves as a proof of various advances and evolution of technologies, which has led to the growth of high performance instruments. And this particular development of instrumentation, it has led to increase in more sophisticated and non-destructive method of analysis. And these non-destructive techniques, they play most valuable role in forensic science, as they cannot be conducted on very small as these particular tests, they can be conducted on very small samples, and it does not even require the extensive sample preparation before the measurement. And with these advanced techniques, quality and precision of requirements can be met efficiently, and this is an important step in official recognition of the quality also. Now, talking about the basic principles of instrumentation, so these instruments, physical property of sample is analyzed by these instruments, and it is chosen in instrumental analysis for determination of its chemical composition. Basically, when we are analyzing any particular sample, we are focusing on its particularly talking about biological evidences. So we are either talking about its physical appearance, or else we are making comparison based upon based upon its chemical composition or biochemical composition. All right. Now, analysis of the sample, it can be of any type, for example, biochemical, organic, inorganic, physical, or analytical. And irrespective of the types of analysis, the main purpose is to serve the extract information about the composition of sample and provide its report. And this is the reason why the instrumental analysis, it is also known as quantitative analysis. You know, how much sample you can extrapolate, you are analyzing that particular sample, and thereafter you are extrapolating that particular result to a larger section of evidence. All right. Now this statement would be much clearer to you when I cite this example. For example, you might have heard about trace evidences, right?
No, ma'am.
All right. So I would like to ask you that you have forensic background, right?
Yes, ma'am. Like I did my short-term forensic psychology and criminal profiling course from IFS Pune.
Okay, okay, all right. So now, when we talk about forensic science, the criminalistics, if I talk about, not criminology, I am talking about criminalistics. So in criminalistics, we are following the, analysis of evidences and instrumentation. It is basically analyzing the evidences and evidences. You can unmute yourself and you can let me know. Example of evidences.
Ma'am, in rape case, we have evidences like semen, hair follicles, and swab. They can be the
Okay.
evidences in a rape case.
All right. So, now talking about biological evidences. First of all, evidence is anything which is supporting or which is connecting any two things. It is a link which connects any two things, right? That would be known as evidence. All right. Now, when I talk about evidences, so in particular, um, if I talk about biological evidences, so these evidences, they have biological origin. They originate from some source which has life in it. All right. So, for example, hair. For example, the sweat, for example, the urine, for example, blood sample, or else even the semen sample, or else the pollen grains which are there. So you might have heard about pollen grains also, which are present on flower. So those are the examples, some of the examples of biological evidences. Even nail and the fibers that the cloth that you are wearing, the basic unit or the fundamental unit of your clothes is fiber. So examination of fiber also, it comes under as a biological evidence only. All right. So that is there. Please give me a second. All right. So these are some of the biological evidences that we were talking about. Now, yeah. So these are some of the trace evidences, as I was talking about, extrapolation of the report which we are getting. So extrapolating it to a larger scale. So for example, you have got trace evidences. So in trace evidences, for example, pollen grain, it is not visible by naked eye, obviously we are going to analyze it using the microscope. Now, when we analyze that pollen grain under microscope, so we will be able to see the structure of pollen grain, and then we will be comparing it with another sample that we are getting. So there is one question sample, one control sample. So we'll be comparing both of them, and then we'll be establishing a link over there. Now, this is the trace evidence that we are analyzing. And now, uh, the first of all, qualitative analysis would be done. Qualitative analysis means checking the quality of that particular um, sample, right? So by quality, I mean I refer to the structural analysis, or how that particular evidence is appearing. So that would provide me an information about the quality of that particular sample, or what that particular sample is. So that would be a qualitative analysis. Next, if I refer to the quantitative analysis, it means that how much of that particular uh, species, or the thing that I'm looking for, how much of it is present in that particular sample which is provided to me. All right. So that would be the quantitative analysis. Now, this particular instrumental analysis, it serves the purpose for both qualitative as well as the quantitative analysis. All right. Now, the type of instrumental techniques used, it depends on the property of the sample which needs to be measured. Now, for example, if I need to measure, if I'm getting a blood sample, and it is a blood drop only that I got. So the police, they when the police collected the sample, they swabbed it using a sterile cotton swab, and then they forwarded it to the laboratory for examination. Now, they have from a single droplet of blood, now they have demanded that we want DNA analysis also. So we want a DNA profiling to be done from that particular droplet of blood that we have forwarded to you. Now, from that blood droplet, it is possible to give the qualitative analysis that yes, this particular sample, it belongs to human. We can do the we can even perform the grouping also, so that which blood group is it. We can determine the species also, but we cannot determine the DNA from that sample, because the sample, it will be consumed wholly. So what we do is, we take a part of that particular sample, we keep it for um, analysis of we keep that particular sample for analysis of uh, blood group and species determination, and the rest of it, it is sent for PCR. It is subjected for PCR amplification. So the sample is amplified. Whatever DNA is present in it, whatever material is present in it, so it would be amplified, and thereafter the qualitative analysis of DNA would also be done. So depending upon, here we have used two different techniques. One is the antigen antibody reaction for determination of blood group, and next would be for the DNA analysis, we are running the PCR technique. All right. Poly Polymerase chain reaction technique we'll be running for that. So based upon our requirement, we are choosing what instrument or which instrumental technique should be applied. All right. Now, the basic principle of instrument employed for chemical or biological analysis is that it can convert the information which it has received from the sample to a form which can be observed and understood, and to basically, or simply put it in a way that the sample which is analyzed, the information is taken from the detector, and later on it is displayed in analog and digital form, so that we can understand and interpret the result. All right. Now, this instrument which is chosen for analysis, it helps, therefore, it helps in the generation of signal, first of all. Thereafter, the transformation of signal from one of different nature. Now, for example, you are determining the level of hemoglobin present in blood. All right. So, the result has been produced by the you have performed the test on that particular sample, the result has been generated. Now how will you understand that what is the level of hemoglobin in that? So for that, the instrument would be firstly creating a signal, and thereafter this signal which is produced, it would be converted into analog or digital form, and then it would be displayed onto your screen. And the third step which is there, it is the amplification of signal. So these are the three basic steps which are included in any of the instrumentation technique that you would be using. All right. Now, though these steps, they are not combined in all instruments, but some a part of them or all three of them, they are present in every instrument. All right. Now, in order to understand the instrumentation techniques, so we need to understand these two important terms, which are analytical technique and analytical method. So first is analytical technique. Now, it is a vital scientific phenomenon which proves to be useful for providing information regarding the composition of a substance. Now, for example, the UV spectrophotometry, which is there, the ultraviolet spectrophotometry, it is an analytical technique. So it would analyze what substance is present. Analytical technique answers the question that what is present in the sample, whereas the quantitative technique, it answers that how much is present. So qualitative is equivalent to analytical technique, and it answers what is present. And if I refer to quantitative, it answers how much is present in that particular sample. Now, analytical method, so it is a definitive application of method to analyze a sample. So how are you going to analyze any particular sample? So what procedure would you follow, for what method would you follow? So that is the analytical method. For example, the UV spectrophotometric analysis of any particular dye mixture or any particular extract which is there. So for that, you need to prepare an extract, and thereafter you have to subject it to the instrument. You cannot directly put it as a you cannot if you need to analyze what is present or what are the substances which are present in a leaf, so you cannot directly put that particular leaf into the instrument and you will get the result of it. That is not possible. You have to extract the components from the leaf, and thereafter you have to subject it to the instrumental analysis. So therefore that becomes the destructive method of analysis. There are certainly non-destructive methods also, for example the IR spectrometry, or else the microscopy also. All right, so these are the things which are there. Now there is the classification of instrumental techniques. So basically it is broadly classified on the basis of three areas. First is the spectroscopy. You are using the light source to see or visualize the elements present. So that is spectroscopy in simple words. Then there is electrochemistry. So from the name itself, it is clear that there will be application of uh, electricity, and electric charge would be applied to a substance, and thereafter, on the basis of the separation, the chemistry of that particular sample would be analyzed. And the third one is chromatography, that is not of use in biological examination, for the examination of biological evidences. So that is chromatography. Chroma means color and graphy means writing. So in chromatographic technique, you are basically producing a graph of the analysis. The analysis result, it is presented in a graph form, and that graph form, it is uh, you know you can visualize it by the different bands of colors which is produced by after subjecting it to the uh, instrumental analysis. All right, now talking about the spectroscopic techniques. So, talking about the spectroscopic techniques, here we'll be focusing on the UV visible spectroscopy, the fluorescence and phosphorescence spectroscopy, and infrared spectroscopy. So, firstly, talking about the UV visible spectroscopy. So, it is a type of absorption spectroscopy in ultraviolet visible region of spectrum. We all know that the light, it is having the wave nature. Here we are focusing on the wave nature of light. So the spectrum of light, in that particular spectrum, we are particularly focusing on the UV and visible region of light in this particular technique, and it lies in the region of 380 nanometers to 720 nanometers. That is the wavelength of light which we are taking into consideration. So in this particular region of light, it is used to this particular light is passed through the sample, and thereafter the results are interpreted. All right, so this spectroscopy, it uses the light in visible and near UV and infrared ranges also, and the absorption in the visible range, it directly affects the observed colors of the compounds which are involved. And atoms and molecules, they undergo the electronic transitions when they are exposed to radiation of this particular spectrum. All right, now next is the fluorescence and phosphorescence spectroscopy. In this particular when I'm talking about these particular techniques, so I am not specifically focusing on explaining the instrumentation right now, because that would be eventually explained to you. Here I'm just briefing you that what these spectroscopic techniques are. All right. Now, in fluorescence and phosphorescence spectroscopy, before I start that, I wish to know that how many of you have heard about the phenomenon fluorescence? Do you know what fluorescence is?
Something like neon colors or
All right. So that is fluorescence, something which is emitting light, right? So that is fluorescence. But fluorescence is actually different phenomenon. Now there are three phenomenons. First is fluorescence, second is luminescence, and third one is phosphorescence. All right. Now luminescence, what we generally refer to when we are uh, when we are flashing a light, a particular type of light on a particular type of material, so it is reflecting back some sort of light, so that is fluorescence. All right. Luminescence is that some material, it has it produces the energy of itself, and it falls in that particular uh, spectrum, that it is radiating out the light, it is radiating out that energy in form of light which is visible to our eyes. All right, so that particular phenomena, it is known as luminescence. All right, we have seen fireflies, right? So these fireflies, they are example of bioluminescence. There are certain materials like radium, they they glow in the darkness, so that is chemoluminescence. All right, so these are the examples of luminescence. When I refer to fluorescence, so I need to firstly um, expose that particular sample of mine or material of mine with some light source, external light source, and thereafter when the light hits that surface of material, it would give out some sort of light of another color. For example, when we are detecting these biological samples from a, a a crime scene. For example, we are collecting some urine sample. Now the urine, it has already dried. How would you distinguish, or else that a particular sample, it is liquid, still liquid in nature. So how are you going to distinguish between those two? It might be present. It is a possibility that water might be present, or some other sort of chemical might be present. All right. So how are you going to distinguish from that? So for that, we, flash a UV light on it, and urine, it gives back the yellow colored fluorescence. So that particular phenomenon which is occurring over there, that is called as fluorescence. All right. Is it clear?
Yes, ma'am.
All right. Uh, Please do respond to the questions which are asked. So that is the way, or that is the only way how I can interact, or how I can get to know that you people are understanding what I'm trying to say. All right.
Yes, ma'am.
So, all right. Now we were talking about those two phenomena. First was luminescence, and second one is um, phosphorescence, luminescence, fluorescence, and phosphorescence. Phosphorescence and fluorescence, they are somewhat similar in nature. All right. Now, uh, in this particular spectroscopy, that is fluorescence and phosphorescence spectroscopy, the emission of photons from electronically excited states, it is known as luminescence. Now, there are two types of luminescence which are there: fluorescence and phosphorescence. Now, they both differ in nature of ground and excited state. And after the first one which we are discussing is that after absorbing the radiation from UV or visible region, the molecules of the sample, they get excited. Now, this electronic excitation, it is supplemented with excitation of molecule to higher vibrational level. So the electron, it is moving from lower energy level to higher energy level, and with that, uh, uh, you know. After some time, it would be losing its energy and then coming back to its lower energy level. That would be the more stable energy level. So the energy which is emitted by that electron is in the form of light energy, and that light energy uh, is the example. That light energy is the example of fluorescence. All right. Now, due to the loss of vibrational energy, the molecules, they return to ground state, and this leads to emission of light. This is known as fluorescence. Now, talking about phosphorescence, so it is also emission of light when molecule, it returns from the excited state to ground state with different spin multiplicity. Now, there is a difference of fraction of second in which the light gets reflected. So that forms the basic difference between the fluorescence and phosphorescence. So the measurement of intensity of fluorescence, phosphorescence as a function of wavelength is known as the spectroscopy. All right. Now, next is the infrared spectroscopy. In this, it comprises of the interaction of matter and infrared radiation. So, in infrared radiation, the energy of the light wave, is not enough to excite an electron and move it to higher energy level. Instead, what happens is the molecule, it just vibrates. The atom which is there, it just vibrates in its own position, or even the molecule which is there, it vibrates in its own position. And because of that vibration, some waves are created, and these waves are detected, and each molecule has its own uh, tendency of sending out the uh, information about its composition through vibrational energy. All right. So that is the basis of infrared spectroscopy. Now, it is used to identify and analyze the chemical structure and even the biochemical structure of any component. And this is the main instrument which is used to produce an infrared spectrum, irrespective of the nature of matter, whether it is a solid, liquid, or gas. And when the wavelength of the infrared radiation is identical to the vibrational frequency of any particular molecule, so then the absorption takes place. And similar to the absorption spectroscopy, the examination of transmitted light, it provides the information about the amount of energy which is absorbed. Next is Raman spectroscopy. It is similar to infrared spectroscopy, and it is used to observe the rotational, vibrational, and other lower mode frequencies. And this spectroscopy, it is used in identification of different biomolecules, and it is the basic principle which underlies this particular technique is Raman scattering of monochromatic light. All right. Now, next are electrochemical techniques. So, in these particular techniques, first one is the conductometry. So, in the presence of electric field,